Today we are going to discuss the model of conduction in metals. When we consider the conduction of current through a metal, we must acknowledge a few things. We must consider something called drift velocity. During an electrical signal propagation, free electrons move in a zigzag fashion, bouncing off the lattice structures of the molecules. When they enter a wire, the same energy is forced to leave immediately following. If there are more free electrons present, a lower velocity would be required for the movement of the current. Also, the diameter of the metal wire itself can increase or decrease this propagation. This all can be calculated mathematically with the following equation. Let's take a look at an example using this equation to calculate drift velocity. Calculate the drift velocity of electrons in a copper wire with a diameter of 2.053 millimeters, 12 gauge, carrying a 20 amp current, given that there is one free electron per copper atom. Household wiring often contains 12 gauge copper wire, and the maximum current allowed in such wire is usually 20 amps. The density of copper is 8.80 times 10 to the third kilograms per cubic meter, and the atomic mass of copper is 63.54 grams per mole. So first we must gather what we know from this word problem. We have been given the current, charge, wire diameter, copper density, and atomic mass. We will also use Avogadro's number to find our answer. Next, we must calculate the density of free electrons using the copper density, atomic mass, and the Avogadro constant. This gives us N equals 8.34 times 10 to the 28th electrons per cubic meter. We also need to find the area of a cross-section of the wire. We use the diameter given to find pi r squared. This gives us A is equal to 3.310 times 10 to the negative 6 meters squared. We modify the equation from before to find our drift velocity. Then we simply plug in the calculated figures from before. Now our final calculation will look like this. After plugging all this information into the calculator, we find that our drift velocity is equal to negative 4.54 times 10 to the negative 4th meters per second. Our negative value lets us know that the free electrons are traveling in the opposite direction of the conventional current. I hope that this video has helped in your understanding of drift velocity. Thanks for watching, and I'll see you next time.